We just co-published a paper with CBCC, Comprehensive Blood and Cancer Centers, which is the largest private cancer center on the West Coast, and Christus Health, which is one of the 20 largest healthcare systems in the United States, with 600 hospitals and clinics, demonstrating that we can detect CTCs in stage 0 breast cancer. We can detect it in stage 1 breast cancer. We're about to publish another paper. We have detected 1 millimeter prostate from a blood draw. The sensitivity of the test is extremely high. We catch it very early because we catch it at the cellular level. We, in fact, have detected cancer at the cellular level before it shows up on imaging. Imaging cannot detect at a cellular level because it doesn't have the resolution. You have billions of cells. You don't have billions of pixels. It's literally impossible. 1 gram of tumor mass kicks off 3.2 million CTCs a day, roughly. To put that in perspective, if you had breast cancer, 1 gram is not even palpable. You can't feel it, really. It's so small, they will often, and most often, refuse to biopsy because they will miss, or they will not get enough tissue. And if you cannot biopsy it, you cannot diagnose it, you can't stain it and give it to a pathologist to examine. So 1 gram, which is not palpable, which is not biopsiable, which is not diagnosable, kicks off about 3.2 million CTCs a day. That's at stage 0. The half-life of a CTC is 27 to 29 minutes generally in the literature. Let's call it 30 minutes to make the math easy. 3.2 million a day is 150,000 per hour. 150,000 times 24 is 3.2 million. Or 75,000, half of that, every half hour, every 30 minutes. That means 1 gram can shed 75,000 CTCs into your bloodstream every 30 minutes. The human body has 5,000 milliliters of blood, plus or minus. Body weight varies from 4,600 to 6,400 generally. At 75,000 CTCs on 1 gram of tumor mass, over 5,000 milliliters of blood, if you divide that, that's 15 CTCs per milliliter per gram of tumor mass. Which means when we take a 40 milliliter draw, that should have somewhere in the vicinity of 600 CTCs per gram of tumor mass. That's at stage 0. A pathologist needs 1, which is why the sensitivity of the test is so high. Because CTCs share certain physical and mechanical characteristics, size, structure, rigidity, lack of malleability, lack of deformability. They're big, they're hard, they're stiff, they don't bend. These parameters enable us to selectively capture those CTCs in our process. It turns out that the physical and mechanical characteristics of CTCs are uniform and homogeneous, the same, across all solid tumor types and their subtypes. Therefore, we will pick them up indiscriminately, irrespective of their source organ, making it a broad spectrum pan-cancer screen. Breast, lung, colorectal, pancreatic, liver, bladder, the principles are the same behind the CTCs. CTCs provide essentially a whole body tissue biopsy. The only novelty here is that we figured out how to take out whole intact tumor cells from a blood sample. Cellular tissue. Everything else we do is standard pathology. Now, in this world of cancer screening, there's a lot of alphabet soup. It's confusing. There's CTCs, ctDNA, cfDNA, MRIs, there's acronyms thrown around left and right. My goal today is to help you understand what those are so you can parse through them and make the right decision for your screening choice, which is our test at Cancer Check. CTCs, circulating tumor cells, are whole intact cells. They have the components of a cell. They have a nucleus. They have a genome with the DNA sequence. They have a cytoplasm, membrane, so on and so forth. When that CTC is dislodged from a primary tumor in transit, typically one of 3 things will occur. A, it will go through cell apoptosis, which is programmed cell death, at which point the cell and its components, including the genome, will fracture into little bits and pieces and be released into your bloodstream. B, it will get eaten by your white blood cells, your macrophages, which is what's supposed to happen. That's your immune function, trying to kill them. It literally looks like a Pac-Man that will chomp it down and crunch it and break it into little bits and pieces, including its components, including the genome. Or C, they will travel through your capillaries, where the shear forces, the physical stresses will fracture the cells into little bits and pieces once again. When any of those events occur, little scripts and scraps of the genome are floating around your blood, little bits and pieces of DNA, incomplete bits and pieces of DNA. What a lot of companies in cancer screening are trying to do today, there's a whole sea of them, is take biomarkers or these little scripts and scraps in a black box, apply mystical, magical algorithms, AI, artificial intelligence, ML, machine learning, NGS, next generation sequencing, heavy computational processing, and extrapolate to guess, do we or don't we have a tumor cell? The problem is, it's a guess. And those extrapolations are highly erroneous. We can debate the quality of that guess based on the quality of the algorithms in the box, but it is a guess. We at Cancer Check do not guess. We take out whole intact tumor cells that are physically placed on a glass slide, that are affixed, put into the palm of a pathologist to examine under a microscope, just like they would a tissue biopsy, because it is cellular tissue. And tissue is the gold standard for pathologists. And the output is a board-certified pathology report. Those are the same reports you get from a tissue biopsy. They're accepted by every physician in the world. You cannot practice medicine without them. So we've got CTCs, which is what we use, circulating tumor cells, whole and intact. The whole cell gives you the whole picture. We've got ctDNA, little scripts and scraps. And the most prominent company there that you'll hear about is a company called Grail. They have a test called Gallery. That test is an irresponsible test that should not be on the market. They just released data 3.5 months ago at AACR, Annual American Cancer Research, for one of their trials. They had to release it. In that trial, their stage 0 detection was 0. Their stage 1 detection was 3%. Their stage 2 detection was 5%. Their stage 3 detection was 15%. That means they are missing 85 to 100% of stage 0 to stage 3 cancers. That is useless for an early detection test. And it is dangerous because it will give you a false sense of security when you may have cancer. The next problem they have is they have a 56.9% false positive rate in their published data. That means they will tell you cancer almost 57% of the time. You have it when you don't. After which you will go through intervention, scans with radiation, colonoscopies, surgical tissue biopsies, all to find out you don't have cancer. Costly invasive interventions. Frankly, at a 56.9% false positive rate, why don't we just flip a coin? We will only be wrong 50% of the time and we'll save $949. This is why you need tissue. This is why you need to put them on glass slides and have a pathologist that is trained to look at these, physically examine them. It is more responsible. We don't like guessing. We want to see tissue. We want to give you an accurate result.